Good evening, kids. So, first of all, do you notice the split screen? Shelby was in this weekend and reminded me how to do this. Um, okay, so law of cosines we've done before. We did those in AP Pre-Calculus, but let me remind you of the formula. It is a squared equals b squared plus c squared minus 2bc cosine a. And the thing that's important here is that whatever angle you're using for cosine is the side that is set equal to. So you could do b squared equals a squared plus c squared minus 2ac cosine b. So as long as these two match, then you're good to go. You can rearrange it how you need to. So this is a pretty straightforward problem. You're given two sides and the angle that's inside of them, which that's the way this has to be set up. BC cosine A. A will always be the angle in between sides B and C. So that's what the requirements are. Sorry. Where with law of sines, you have an angle in the side opposite. So side A, or angle A, side A. But with law of cosines, you can't make that pair. Like if we tried to use law of sines here, we tried to use it here, we would have to have this side. Or if we tried to use it with B, we would have to have this angle. But we can't make a pairing. So we have to check for law of cosines. Now, law of cosines does not involve the ambiguous case, so you'll never have more than one choice, more than one triangle possible. What could happen, though, is you have three sides that won't connect. Like if you had, say, 10 and 15 and 1. Like there's no way, because you'd have, and you know this angle is, say, 60. There's no way to bring this down to make this short side fit this side. So there are times when law of cosines will give you no solution, but it will never give you more than one triangle possible. So like I said, this is a pretty standard or straightforward problem. We just set up for side A, so we're a squared equals b squared plus c squared minus 2 times b times c cosine of our angle, which is 51 degrees. So when it's written like this, you can just type it all in the calculator at the same time. So we can go ahead and hit second square root 27 squared. There we go. 27 squared plus 42 squared minus 2 times 27 times 42 cosine 51. Make sure you're in degree mode, which I am, equals. And so we get that side A is 32.6. Let's see what it tells us for rounding. Lengths and sides to 1 decimal place. All right. So let me fill that in. Okay, so now we can go to side B. Now you would think that you could potentially use law of sines here because you do have a side and its opposite angle, but because law of sines can sometimes result in two triangles, that could happen here. And you have to figure out which triangle is right and which triangle is the wrong triangle. So I have a little rule that says if you start with law of cosines, you finish with law of cosines. And so we're always going to do that. Like I said, you could use law of sines here, but when you explore the fact that you could get two angles sometimes for the angle that you're finding, and then you have to go through and figure out which angle is the right angle for that particular triangle. It just kind of gets a little bit sketchy. And so I just say start with law of cosines, finish law of cosines, and that way you know that you're getting the right one. All right, so let's find, we'll go to angle B. And so since we're finding angle B, then our formula would be b squared equals a squared plus c squared minus 2ac cosine B. Now, we know side B is 27. We know side A is 32.6. We know side C is 42. What we don't know is angle B. So you can't just put this all in the calculator at one time. So we have to do it in parts. First, let's square 27. And what we can put in is this piece right here. So 32.6 squared and 42 squared gives us 2,826.76. Then we can also put in this part. That didn't do right, 2 times. That's better. 2738.4 cosine B. All right, and now here, this is the only area where some kids will get a little bit messed up, and they think that they can subtract these two things together and then divide both sides by that number to get cosine of B. But if you think of this as, I don't know, some number, we'll say 3 minus another number times something, you know that you can't take the 3 minus the 4. When it looks like that, it's a little more obvious that you can't combine the 3 and 4. And that's what this is essentially saying. It's a number minus another number times the cosine of B, whatever that happens to be. So what we have to do is first subtract this. So negative 2097.76 equals negative 2738.4 cosine of B. Now you can divide by the coefficient of cosine of B. So we get cosine of B equals this mess, and then do inverse cosine of that answer, and we get E. I'm going to write it so you have it in your notes, what we did. 39.999, so B is 40 degrees. All right, and now that you know two angles, we know the 51 degrees we were given, and we know the 40 degrees. So 180 minus 51 minus 40 is 89 degrees. Okay. Now, the other thing that could happen is you could not be given an angle at all, in which case we would solve it much like we did this part where we were finding an angle. And you can start anywhere. So let's, because we have all three sides, so we can start with any angle. So let's start with angle A. So the formula there would be a squared equals b squared plus c squared minus 2bc cosine A. Fill in what you know. Now I want you to watch what I'm going to do here. 27 squared, and I'm going to subtract 15 squared. Then I'm going to subtract 25 squared, get an answer. So that gives me negative 121 equals 2 times 15 times 21. Whoops, 2 times 15 times 25. All right, now, again, watch what I'm going to do here. Inverse cosine of negative 121 divided by 750. So angle A is 99.28. I'm checking it because it's not matching up with what they gave us. So 27 squared minus 15 squared. Negative 750. There we go. 80 point, one decimal place, 80.7. Here I was showing you how to kind of shortcut writing all this work down, and I messed up. Okay, and now we do the same thing for angle B. And so that would be 15 squared minus 27 squared minus 25 squared. And we're going to divide that by negative 2 times 27 times 25. Inverse cosine of that answer, and I get 33.2 degrees. And then you just subtract them. So 60. .1 degrees. Very good. Okay, so I don't feel like I need to do another one that's just like this, but I will give you the answers. We got 6.8 here, 71.7, and 88.4. Same here, pretty straightforward. 32.5, 42.2, and 83.8. All right, now In this particular problem, it's just kind of warning you that you could potentially get one that has a triangle that doesn't exist, so be careful. In the first one, a triangle does exist. FYI, the only time it's possible for a triangle to not exist is if you're given the three sides. So anytime you're given an angle and the other two sides, a triangle is going to exist. Let me say that again. When you're given the angle that's between two sides, a triangle will exist. Because what you're given is this, and you're given side length, an angle measure, and a side length. So you just have to connect them and give the side lengths there. All right, there's your answers there. Now this one, same thing. It's given us three sides. We have to do the inverse here. So this one, it's actually possible that maybe a triangle doesn't exist, but a triangle does exist, and the answers are 60.8, 102.9, and 60.3. Now, we're going to do number 7 because this is one where a triangle doesn't exist. So we're given three sides. Pick an angle to start with. We'll do A. Fill in what you know. And then let's work our magic. So 10 squared is 100. And I'm going to actually work it all out so you can see what happens. So we're going to combine these. Divide. And we get 1.4857. Now, if any of you remember anything about your trig values, sine and cosine values have to be between -1 and 1. So when I try to do the inverse cosine of a number bigger than 1, it's going to tell me non-real answer. So this is where a triangle does not exist. So when you're doing your division here, you'll get either a positive number bigger than 1 or a negative number smaller than -1. And that's going to, when you try to do the cosine, it's going to not exist. Okay, at 8, triangle exists, 8.2, 34.5, and 127.5. Okay, so word problems. Or actually, Heron's formula. So we had the area formula in the last section, which is 1/2 AB sine C. What do you do if you're finding the area and you're given three sides and it's not a right triangle? Obviously, if it was a right triangle, you could do 1/2 base times height, but this is not a right triangle, or at least we don't know. So Heron's formula is the square root of s times s minus the side length of A times s minus the side length of B times s minus the side length of C. And so the only thing you need to find the area given three sides is what is s. And s is 1/2 the sum of all the sides. And so you'll see it either written that way, or some books will just write it like A plus B plus C divided by 2. Notice this is not the area. The area would be 3 things divided by 3. This is 3 things divided by 2. Okay, so to find the area of this side, the first thing we have to do is find S. And our S in this case is 17. And so now when we put this in the calculator, and it tells us to round to the nearest tenth, which would be 35.0. So there you go. 10 is the same thing. You should get 147.2. Now, this is going to be the same thing, except that they gave us our numbers in feet and inches. And it wants our answer in feet. So we have to figure out either the decimal version of each of these measurements or write it as a fraction. Now remember, your inches are out of 12, so each of these would be, so this would be 8 feet and 4/12 of a foot. This would be 10 feet and 2/12 of a foot, 5 feet and 6/12 of a foot. So the first thing I thought of was, well, I know that 4 divided by 12 is 0.33333. So then that ruins using the decimal version. Like I can't write that in exact form. So I was like, well, I don't really want to enter this. This is what I would have to enter. When you use the graphic calculator to enter a mixed number, you have to enter it as plus. So it'd be like 8 plus 4/12, and then 10 plus 2/12, and then 6 plus 5/12. The other option would be to make these mixed numbers. So this would be 8 times 12 plus 4, which is 100 over 12. 10 plus 12 is 120 plus 2, 122 over 12. 5 times 12 is 60 plus 6 would be 66 over 12. So you could enter them that way. It's whatever you prefer, but you do have to enter them in exact form. If this were multiple choice, you probably could just round the decimals and pick the answer that was closest. But since we have to actually enter the answer ourselves, I don't know that I would trust using like 0.33 instead of the actual answer, instead of 4/12. All right, so anyway, if you add those and then divide by 2, you're going to see that your S is equal to 12. And that's probably where the difference is going to be. Like if you did the rounding, you'd probably get like 11.9 or 12.1. But then we have to enter it all again. So we're going to do the square root of 12 times 12 minus, and so here's where you'd either enter this or enter this. And I know that 10/12 is reduced, but I mean, 112ths reduced, but why would I take the time to do that? Times 12 minus 122. Oh, what? And so we're going to get nearest tenth of a foot, so 22.9. And that's just them being mean. Like, why would they even do that? It's just stupid. Okay, this one's pretty straightforward. The answer is 5,460. You just find the area. Okay, last one. So first, we need to find the area, and it gives us the sides. So that's great. Find the area, and when you do this, your S is 412, and you're going to get big number. Oops. But this question is asking how many acres, and this would be our yard squared. So they give us the conversion that 1 acre is 4,840 yards squared. So we would need to divide this, and this is what you get, and so it ends up being about 6 acres. And then it's asking us for the cost. So it tells us that every acre takes 2.4 hours at a cost of 22.21 per hour. So you're going to take your 6 acres and you're going to multiply by 2.4 and multiply that by 22.21, and you should get $1,514. It actually ends up being $1,513.82, but it says to round it to the nearest dollar. So nothing too scary there in that one. None of those word problems were too difficult or unusual, other than the inches thing. By the way, if all of these have been like, for example, 6/12 is 0.5, so I could have just used 5.5 for this one. But 2/12, what just happened down here? 2/12 is not a perfect or an integer value or a decimal, perfect decimal, and neither is 4/12. So since those are values we'd have to round, I didn't take the time to do it with a round answer to see if we get something close. So I don't know if you want to take the time to do that to see if you could chance it. But if I remember right, none of those was on the quiz or test. So, all right.